Let's do an example involving supply and demand. In this example, the first table represents a demand function. We have the price in dollars per unit and the quantity demanded, how much at a given price consumers are willing to buy. In the second table, we have a supply function. So we have the price in dollars per unit and then how much the manufacturers are willing to supply at the given price. And we're asked, what is the equilibrium price and quantity? Okay, so to do this, the way we're going to do it is solve an equation. So the first function is going to be a function d of p, and the second is a function s of p for supply. And to find the equilibrium price and quantity, what we need to do is set d of p equal to s of p, and then we'll solve for p, the equilibrium price. Okay, in order to do this, we're going to have to first express d of p as a formula and s of p via a formula. So what's nice about these particular examples is that the quantity demanded and the quantity supplied are both linear functions of the price. In particular, notice that as we move the quantity up by 5 units, the price goes down by 10 units here. And as we move the quantity up by 5 units in the table here, the price goes up by 30 each time. So we have a constant rate of change, that is, these are linear functions. Okay, so our first step is to write the demand function as a linear function and then to write the supply function as a linear function. So the demand function by the point slope formula is going to be the slope times p minus p1 times d plus d of p1. Okay, so we need to figure out the slope. So we'll take these 2 points and we'll figure out the slope. So we're going to have the quantity demanded, 10 minus 5, divided by 165 minus 175. So that's going to be equal to 5 divided by minus 10. So that's going to be equal to minus 1/2. Now the fact that you got a negative slope here should be expected because we know the demand function is a decreasing function, so the slope should be negative. So that's our slope, so minus 1/2. Then we got p minus, now we take a point, let's take this point. The p1 for this point is 175, plus the d of p1 is going to be 5. So that gives us a formula for d of p. Now let's move on to the supply function. S of p is also a linear function, so we have m times p minus p1 plus s of p1 for some nice point p1 s of p1. So in this case, however, the slope is given by, for example, these 2 points. So let's look at that. We have 10 minus 5 again. That's a difference in quantity. And then the difference in the independent variable is 35 minus 5. So that's equal to 5 over 30, which is 1/6. So the slope is 1/6. So we get 1/6. We have p, and then we have a p1. We can use this point, so we'll have minus 5 plus, and then s of p is 5. Okay, so now we have our expressions for the supply function and the demand function. So here is the ones we were interested in. Now we have to set them equal and solve for p. Okay, setting them equal and solving for p looks like this. Minus 1/2 p minus 175 plus 5 is equal to 1/6 p minus 5 plus 5. Now to make things easier, I'm going to just multiply both sides by 6. That will get rid of the annoying fractions. So 6 times minus 1/2 is minus 3, so I get p minus 175. And then 6 times 5 is 30. 6 times this will just clear out the 1/6. and then 6 times 5 is 30. Okay, notice now the 30s go away, they cancel, and then I can multiply this out, I get minus 3p plus 3 times 175. So 3 times 175 is going to be equal to 15 and 22 and then 525. So I should get 525 here is equal to p minus 5. Okay, now I put the p's on one side and the constants on the other, so I'll add 5 to both sides, get 530, and I'll add 3p to both sides, get 4p. So then p is equal to 530 divided by 4. Okay, so that's my equilibrium price. Now, for my equilibrium quantity, I need to take this value and plug it into either S or into D. Now I'm going to plug it into S. It doesn't matter. I should get the same value if I did things correctly. So now what I have to find the equilibrium quantity, I plug this in. So this is going to be S of 530, which is 1/6. 530 over 4 minus 5 plus 5. So that's the equilibrium quantity. And if you want to, you can use your calculator to get a decimal approximation.